Assalamu alaikum, grade 12. Inshallah, today we are going to start the lesson 5, chapter integration, the integration expressions of the form f prime of x over f of x. In the first semester, we have studied the derivative of ln of x. So if we say let f of x is equal to ln of x, then the f prime of x is equal to 1 over x. So if we go in inverse way, if we integrate 1 over x dx, okay, the integral of 1 over x dx is equal to ln of the modulus of x plus c. And the integral of the function f of x over the f prime of x over f of x dx is equal to ln of the modulus of f of x plus c. This rule we are going to study, inshallah, this day. Okay, the integral of f prime of x over f of x dx equals ln of f of x plus c. As you see here, the 1 is the derivative of x. The 1 is the derivative of x. So the integral of 1 over x will be ln of the modulus of x plus c. This one also in general, we say the integral of f prime of x over f of x dx equals ln of the denominator f of x plus c. This is the general rule here that we are going to study. The integral of f prime of x over f of x dx equals ln of the modulus of f of x plus c. As you see here, the top is the derivative of the bottom. The top number or denominator of the expression is the derivative of the denominator. So if we take here a simple example for that, if we say the integral of x over x squared plus 1 dx, what do you think? How to solve this one? Just look at the denominator here, x squared plus 1, and think of what is the derivative of x squared plus 1. You know the derivative of x squared plus 1, okay, the derivative of 1 is just 0, but the derivative of x squared is 2x. But in the top written just x. So we should multiply this top by 2, and if you do this, you have to divide outside by 2. Now we have the top 2x is the derivative of x squared. So the answer simply here will be half ln of the modulus of the denominator, x squared plus 1 plus c. Okay, so this is the answer of this question. Let's see here this example, work out these integrals. Question A, the integral of 6 over x squared plus 9. So to carry out what we have studied in this topic here, the formula of, or the integral of f prime of x over f of x dx. Okay, as you see here, this 6 is not the derivative of x squared. We know the derivative of x squared is 2x, but written in the top here, just 6. There is no x here. So this one is not regarding to this formula. This is another one. As we have studied in the previous topic, the integral of what? Do you remember? The integral of 1 over x squared plus a squared dx. That will be 1 over a tan minus 1 x over a plus c. Do you remember this? We have studied this in the previous topic, okay, lesson 4. But here, so we have to use this formula here. So this one is the integral of, you can take this 6 outside. It will be 1 over x squared plus the 9 could be written as 3 squared dx. So keep 6 as it is. So it's 1 over a, means 1 over 3, tan minus 1 x over 3, x over a plus c. Okay, if we multiply 6 by third, it will be 2 tan minus 1 x over 3 plus c. Next one, look at this one, the integral of 6x over x squared plus 9. What's the derivative of x squared? You know that d dx of x squared is equal to 2x. Look at the top, the numerator, written there 6x. 6x is not the derivative of x squared. But you know that 6x, okay, could be written as what? 3 times 2x. So this 6 could be written as 3 times 2. 3 times 2x. Okay, so 6x could be written by this way, the integral of, you can take this 3 outside, and in the top 2x over x squared plus 9 dx. Now the numerator is the derivative of the denominator. 2x is the derivative of x squared plus 9. So the answer will be what? 3 ln of the modulus of x squared plus 9 plus c. This is the answer of this question. Here, example 7, written in the book, find the integral of tan x dx. You know that tan x is equal to sine over cosine. Tan is sine over cosine. Okay, so this question could be written as the integral of sine x over cosine x dx. And what's the derivative of cosine? The derivative of cosine is negative sine. But the top here is just a sine. So you can multiply this sine x by negative and divide outside by negative. You know that negative times negative is positive. Okay, so now the top is the derivative of the bottom. Negative sine x is the derivative of cosine x. Okay, so the final answer could be written as negative ln of what? The modulus of cosine x plus c. You can end your answer here, but sometimes we need to extend our answer because from your previous studies for the logarithms, okay, you can take this negative one here. So this one could be written as the ln, the modulus of cosine minus 1x plus c. You know that cosine minus 1, it's 1 over cosine x plus c, 1 over cosine, that is secant. So ln of the modulus of secant x plus c. Okay, so you should know that the integral of tan x, it is negative ln of the modulus of cosine x plus c, or equal to ln of the modulus of secant x plus c. Now let's come to exercise 5.5. This is question 1. This one is very simple question. The integral of 1 over x plus 1. You know that the derivative of x is just 1. So here the top is the derivative of the bottom. So once you have this, the answer directly will be ln the modulus of the denominator, x plus 1 plus c. Here, you need to find the integral of x squared over x cubed minus 3 dx. See شباب, here x cubed and in the top x squared. You can notice that here the highest index in the top is less than the highest index in the bottom by 1. Once you have this, just think of this formula. ln of the f prime of x over f of x. Okay, here the derivative of x cubed. What is the derivative of x cubed? The derivative of x cubed, you know, it is 3x squared. This is the derivative of x cubed, equals 3x squared. But in the top here, it's just x squared. So you have to write here 3, and if you multiply by 3, you have to divide outside by 3. Okay, now the top is the derivative of the bottom. So the answer of this is third ln of the modulus of the denominator, x cubed minus 3 plus c. Again, look at this one. 2x cubed minus 3x squared plus 12. Now look at the denominator here. Highest index is 3. The top highest index is 2. So think directly of our formula today. What is the derivative of 2x cubed? You know that d dx of 2x cubed minus 3x squared plus 12. If you differentiate this, the derivative of 2x cubed is what? 6x squared. Just multiply 3 by 2, which is 6. Okay, decrease the index 1. So 6x squared minus here 2 times 3 is again 6x. Okay, and 12 will be 0. So 6x squared minus 6x. But here in the top, we have just x squared minus x. So if I multiply this quantity by 6, now this one could be written as what? The integral of 6x squared minus 6x all over the same denominator. 2x cubed minus 3x squared plus 12 dx. But if you multiply up by 6, you have to divide outside by 6. Because here we multiply by 6, that means you have to divide outside by 6. Now the top is the derivative of the bottom, so the answer will be 6 ln the modulus of the denominator. And this is the answer of this question. Next one, here we have the integral of e to the x over e to the x plus 4. We know from your previous studies that d dx of e to the x is itself. The derivative of e to the x equals itself, e to the x. So if you differentiate e to the x, it will be itself in the top. So simply the answer here will be ln of e to the x plus 4 plus c. Here, find these integrals. The integral of tan to x dx. The integral of tan to x dx. Okay? Before we have studied the integral of tan x dx. What's the integral? Was the integral of tan x dx. We solved this one before. The integral of tan x, it was negative ln the modulus of cosine x plus c, or we say it is ln of the secant x plus c. We solved this one like this before. The integral of tan x is the negative ln of cosine x plus c and ln of the modulus of secant x plus c. Okay, but what is the difference between this and this? Here tan 2x, here tan x. So you should divide by this 2. So the answer will be negative half, because of this 2, negative half ln of cosine, not x, cosine 2x plus c. Or you can say equals what? Half, if we use this one, half ln of the modulus of secant 2x plus c. This one is the integral of cotangent 0.5x. The integral of cotangent 0.5x dx. What about the integral of cotangent x, not 0.5x? The integral of cotangent x dx. Okay, you know what is cotangent? It's cosine over sine. So cotan is cosine over sine. So this one will be the integral of cosine x over sine x. Okay, the derivative of sine is cosine. So simply the answer of this equals ln of the modulus of sine x plus c. This is the integral of cotangent. What about the integral of cotangent 0.5x? So as we did previous question, you should divide by 0.5. So we say the integral of cotangent 0.5x dx is equal to, just divide by 0.5 the ln, the modulus of 1 over 0.5 sine 0.5x plus c. You should here write this answer in the simplest form. 1 divided by 0.5, that will be 2 ln of the modulus of sine 0.5x plus c. This is the answer of this question. Integrate, you need to find the integral of cosine 2x over sine x cosine x plus 4. We have studied before this identity. Sine 2x sine double angle equals 2 sine x cosine x. But here we have sine x cosine x. So from this identity, we can say that sine x cosine x equals, if you divide by 2, it will be half sine 2x. So sine x cosine x equals half sine 2x. So we can write this here. So this one will be the integral of cosine 2x as it is in the top, and down, instead of sine x cosine x, we can write it as half sine 2x plus 4 dx. Okay, now think of what is the derivative of half sine 2x. D dx, okay, of half sine 2x is equal to what? Just keep half as it is and multiply that by 2. The derivative of 2x is just 2. The derivative of sine 2x is cosine 2x. 2 and 2 will be cancelled, so it will be cosine 2x that is written here in the top. So in case of the top is the derivative of the bottom, so the answer will be what? ln of 0.5 sine 2x plus 4, then plus c. So this is the answer of the last question. See you next lesson. Assalamu alaikum wa rahmatullahi wa barakatuh.